All right, these last two sets of questions really come from section 3.6 more than anything else, where we're just kind of looking at our charts. You can use your charts for all this, and we're comparing the three graphs. So again, and I labeled them for you. So f of x is the line, g of x is the quadratic, h of x is the logarithm. All right, so the first thing I would do is make sure you know which one's which. And I would identify with your chart. So this is a line. All right, this has got the squared. So if you go through your chart, find the one with the square, that's a quadratic. This is the log. Oh well, that's the hardest one to find, is the logarithm. So these are the three charts you need to be referring to: the linear, the quadratic, and the logarithm. Okay. As we go through this, so first things first, compare the domain and the range. Hopefully, you'll notice that the line and the quadratic, that would be this one and this one, they both go left forever, and they both go right forever. Okay, which left forever, right forever is all real numbers. So f of x and g of x are all real numbers. And it doesn't tell you how to state it, so you can use either one. I'm going to use set builder. X is a set of all real numbers. I don't know why I'm using that. If you use interval notation, it's negative infinity to positive infinity. That's fine too. Logarithms, you can look at the chart, are not all real numbers. So h of x is a little different. You'll notice it says c over b, and then it's either to the right forever, to positive infinity, or to the left for negative infinity up to that point. Okay, so here's what we're doing. We're going to look at this. That's your vertical asymptote, and it's going to the right. So it's at c over b, which is x bar x is c over b is negative 3, and it's going to the right, so x is greater than negative 3. Or you can use your interval notation, negative 3, comma, infinity. And yes, that's a negative sign. Okay. The ranges of the function, same idea. Use your charts as much as you can. And hopefully you'll notice that two of them are the same. The line goes up and down forever, and so does a logarithm. It goes down forever and it goes up. It just doesn't quite look like it's going up forever, but it is, slowly. So in that case, f of x and h of x have the same range. Their outputs are the same, have the same possibilities. So again, that's y. Y is a subset of all real numbers. Or if you use interval notation, that's fine. It doesn't tell you which one to do. Negative infinity to positive infinity. Your g of x, we'll draw a line right here so that we can differentiate between the two. Your g of x, okay, again, that's c over b, comma d, c over b, either up or down, positive infinity or negative infinity. And you notice it's going up. Up is the positive infinity side, up is the greater than side. So it's y bar y is greater than or equal to, because you can be that point, y is greater than or equal to negative 3, which is your d value. I'm sorry, it doesn't say c over b, it says your d value. I apologize. Or you can say box, actually got a pencil, not the eraser, box, negative 3 to infinity, because you can be that point. Okay? Compare the x-intercepts. X-intercepts, yay! Well, the x-intercepts are all different. All right, so you've got that one for the logarithm, that one for the line, and these two for the quadratic. So your x-intercept. So I'm going to go and do the ones I can see. So let's do this. F of x, that's the line, is at 2. So f of x equals 2 comma 0. H of x, that's the logarithm, that's at negative 2. So h of x is at negative 2, 0. And g of x has got two of them. Again, I'll put a line here so we can see. Has got two of them. And you're going to have to put them in your calculator to calculate them. Again, just stick them in your calculator, go to second, calculate zeros to find those, and pick a left side and a right side. Again, I don't have a calculator with me, so I have to use a program that I got on my computer that'll do it for me. I know, Mr. Hunter's cheating. X minus 2 squared minus 3. I'm actually using something called Desmos, which is online. You can find it too, but remember, you're gonna have to use your calculator. And you don't get Desmos on the test, and you get 0.27 comma 0 for one of them, and you get 3.72 comma 0 for the other one. And so those are your x-intercepts. Your y-intercepts. Okay, your y-intercepts. Well, where do they cross the y-axis? Well, you'll notice they all cross right here. So you can say all are at, was 0, 2, is that where it was? No, 0, 1. 0, comma 1. Do any of them have asymptotes? Well, again, you can check your charts and notice that, nope, no asymptote, nope, no asymptote. Yeah, that's got an asymptote. So h of x, and you can follow your chart, is at, I want to put a colon because, is at x equals negative 3. And again, I got that from looking at the chart. It's at negative 3. Or remember, it's x equals c over b, which your c value is negative 3, your b value is 1. Negative 3 over 1 is negative 3. Positive 3. Lose my mind. Compare the maximums or minimums. Okay, again, max and mins. If you look at your charts, you'll notice, hey, linears don't have a max or min. Those don't have a max or min, but quadratics do. All right, so again, you can follow the charts, look through the numbers and all that sort of stuff, or you can look at your graph and say, hey, look, my quadratic, right there, that's the lowest point, therefore it has a minimum at negative 3. Okay, so you can just read the graph, compare maximum or minimum. It's like, so g of x has a minimum at y equals negative 3. Cool? And that's those ones.